Okay, so hello and welcome back to another Unity Shade tutorial. I have not made a video in quite a while because I've been away for quite a few weeks in the holidays because, holidays I want to do stuff. But now that I'm back at home and everything, I do plan on making daily videos again. Once I got back and I was on my computer for like a few days just to, get back into things, my Photoshop and basically a lot of things just stopped working. So luckily I got Unity in my games and quite a lot of the code stuff back up and running. And my files weren't damaged, but basically I just can't use Photoshop at the moment or anything. So I'll be able to do these videos and output them anyway. That's fine. I just won't be able to make. Well, I can't access my Photoshop thumbnails, so I can't just like make a quick change to the new thumbnail. So the thumbnails for the next few videos, at least for the next few days, will just be like default ones, or I could make really quick filler ones. But as soon as I can get Photoshop working again, I will go back and make them. So that's just a temporary thing in case you're watching these as soon as it come out. In this one, we're going to be making a post-processing effect shader just to show you how to do one, and you can make your own. Because as you know, you can get Unity like add-ons or external scripts, and they have little nice interfaces on the editor, and you can tweak, the how much red there is or whatever. Now, so far, the only shaders, obviously, I'm showing off some of them here. We've done the like kind of moss 2 texture shader where it blends between the two on the angle. We've got the vertex shader there showing you how you can have like an offset versi, and then here the wave. This one is a bit different because these are applied, the shaders are applied to materials which go onto the objects directly. But with post-processing, it's the whole point is you make everything in the scene, then post-processing is kind of like a camera layer on top. Your post-processing shader is applied to the camera, not to the object. And with that, you can make the whole scene render in a particular way without having to like apply a red shader to each object or something, because that would be stupid. So I'm going to show you how to set up that, and obviously you can go make your own. So yeah, let's get into it. So first of all, we want to make a shader to do something, and handily enough, I don't know if that's the saying, you can right click and create, and while we create a blank shader normally, like a standard one, or an unlit, there's an image effect shader, which is basically what we want. So let's create that, and we'll call it post-processing. I mean, obviously mine's just in like a real stupid test room, you might want to call it something better. But anyway, we'll open that up in Visual Studio, and it looks just like a normal shader. So let's just go through it. Obviously there's the name, it's in the hidden thing, which means it doesn't show in the editor. It takes in just a texture, and what does it do? Call off, Z-write off, Z-test always. I know what this means, but not 100%. So basically call off means that, so when you render something that's transparent, for example, like when you're rendering a transparent object, what it does is, if it does cull, if it has backface culling, it means that it ignores the back, well, whatever is behind the object. Like how to explain this? So let's say we have a cube. So here's our cube. This is a horrible cube. So when we render it, right, the camera will be rendering all this, whatever we see, it's rendering. But to save, well, effort and processing power, what it will do is, because it knows we're not going to be able to see the back face, or like any of the, basically the back face, the bottom face, that one, whatever we can't see, it won't render it, because why would it render it? It would try and render it and it wouldn't be used because we can't see it. So that's why you can change culling to either have like front face culling, back face culling. You can do cool effects with that by ignoring certain things. So that's cull off, so it doesn't ignore anything. It means we're not culling anything, we're not ignoring anything, we're going to see everything. Z-write is to do with depth, and Z-test always. I mean, as you see here, no culling or depth basically. This is just a camera shader, it's just on the camera. Then here we go to standard pass, CG program, vertex function, fragment function. This is just like normal, obviously. This is what goes into an app data structure, and vertex to fragment, right, vertex. Anyway, this is normal. And this is basically saying, yep, for every object we see, its vertex is going to be where it is normally. We're not changing any of that. But for the fragment, because we want like maybe we'll want it to increase the redness. So what it does now currently is it says, so this pixel we're working on, its color is, it calculates what it should be from the texture knowing the UV coordinate. I've covered this in previous tutorials. If you don't understand what I'm saying, go back and watch those. You might understand it a bit better. This is a note put in by the Unity people, just invert the colors. This is just the basic default one. It takes the RGB of what we've got and it does 1 minus. And if you know anything about this, if you 1 minus a value, you get the inverse of it. Because if all the values for RGB, now sometimes when you get RGB values, it's between 0 and 255, whereas in this, it's between 0 and 1. But obviously, the 1 is equivalent to 255 as such. It's the same scale, kind of. No, it's a different scale, but the same, does the same effect. So if we take a value, let's say our red value is 0.2. If we do 1 minus 0.2 is 0.8. If we had 0.8 and you do 1 minus, it would be 0.2. So basically, it inverts the colors. Now, we're just going to comment this out for now. So what it does is it says, hey, here's our color, and let's not do anything to it because we commented it out. And let's return color. Now, one thing to note is when you have a shader on an object, it renders, it calculates it for every pixel of that object. The thing is, that's fine and all. You might have a small object, might be a big object. The thing with screen image effect, like post-processing, is that it happens for every single thing on the screen. And as you can imagine, what shaders are is basically it's code that tells your computer how to render things. And this code gets run for every single pixel on the screen if it's on a screen space one. Because obviously we render all the objects and then this effect on top. We take whatever we currently got. So let's say we've got this code here and we're saying, hey, this pixel here for the background is purple, purple, purple. Then we've got this object here which says wherever the vertices are and connecting them, it's all light blue, and then here's red. Once it's got all that information, before it actually renders an image to the screen, if you look up here, you can actually see the FPS. We're currently at 74. We've got some animated stuff and it's not properly optimized. But basically, so we see this color here. Now, if we had a layer on top, what it does is it gets, so let's say like this. This is our frame we want to render. It's going to take this image, if we took a screenshot of this, it's going to take this image and it's going to apply the new camera post-processing shader on top of all of these pixels. It's going to go for each pixel and say, here's our purple pixel, let's increase its red. Red. We go to the blue one, let's increase its red. It does the same thing to everything, so it's kind of like an overlay. It's like you're putting a filter on something. That's basically what post-processing is. That's why, as you can imagine, adding lots of post-processing effects can be can have quite an impact on performance. Now, the thing is, this code here, we can't just like drag a shader onto the camera. It doesn't work that simply. We're going to have to write some code for the camera, and that's why whenever you get any add-ons for post-processing, you have to apply something to your camera, because it's basically what lets it work. Now, if we go to our camera, we're going to add a script called post-processing. I probably shouldn't call it just post-processing. Post-processing camera. I don't know. So here's the script. Sure. Just make sure this is saved. Okay. So here's post-processing camera. Everything's fine. Let's just stop the scene. Okay. So post-processing camera. We have a C# script. Now, the thing with this is that if we write code inside scripts like this, all the calculations and the code is run on the CPU. Your processor does all the calculations. Hence, I don't know how much you all know about computers and the processor and inside and all that lot. But basically, the processor has a component called the ALU, the arithmetic logic unit, and arithmetic meaning maths and mathematics. So literally, all it does is it just adds and subtract. It does binary calculations in ones and zeros. Obviously, we program in Unity in C#. C# gets converted down into machine language from the programming language, which is more human friendly. Then once it's in a machine language binary, it does the maths calculations and it gives back data, and then it's all about converting data. That's all computers are, just data, ones and zeros. That's what people mean when they say, it's all ones and zeros. So if we wrote in here basically to do, we can write our own shaders as such in here. Problem is, it's going to be really performance intensive. It's going to be stupid, because the whole point of graphics cards existing and graphics parts of your computer is that they have kind of lots and lots and lots of little ALUs inside them to do the maths. So your processor will have one, or I'm not sure if it's one per core or if it's just one, but I think it's just one in general, and it can do, if you have an 8-core processor, it can do 8 tasks at once. As you can imagine, you want to do more than that, especially when you're rendering a scene with graphics. So that's what graphics cards are for. They have lots of little ones that are optimized for doing these kind of calculations. Now, that's why shaders like shaders are run on the CPU, GPU, sorry, graphics processing unit. Anyway, a lot of terminology here that I hope makes sense to you. If you look into shaders, this is all relevant stuff. Now, we don't want to actually write the shader in here because it'll be very, very laggy. We'll like go down to like a few FPS probably. If not, it'll just crash. So we want to tell it to basically the camera to take in a shader to render. So there is a function, as we have like void start and we have void whatever, like pre-built functions on here, there is one called on render image. And as you see, it's called after rendering, after the rendering is complete. So if you just press enter, boom, you get your pre-made kind of function here. So this is code, and as you know, just that's the thing, any function is just, the only difference between function to function is when it's called and what it takes in. So this is just a function which is called when the image is rendered, and it takes in render texture source and render texture destination. Now, the thing is, it takes it in, but we don't have to write our own thing to pass it in because it's a pre-built function. It already passes it in itself as such. So basically, this here source. Okay, a render texture. We can have like an extra camera be a render texture, or output to a render texture. Sorry. So the source here is literally just the image that it has currently before it's getting showed to us and before post-processing is applied. So basically, source, if we don't do anything with source, it's going to just appear on the screen. But we can do something with it before it gets to us, basically. So we can do graphics, so inside the graphics class, so and we can do blit. Now, I don't know what it's going to say about blit. Let's see. Copy source texture into destination render texture. So that's basically, that's exactly what we want, isn't it? So it copies the source texture, so source, we're going to pass in source, into the destination render texture. So let's pass in, this is a function, so we're passing in source, comma, destination, and it needs a material. So we're going to say public, like post process. Well, sorry, it's a material type, so it's a material called post processing mat. Because your post processing stuff has to be on a material. Shaders are just shaders are the code, materials are the interface. So we need to pass in post processing mat third. Okay. Now, if we go back and we go to the camera, it's going to take a second. If we look, we put the post-processing code on here. It wants a material, so let's create a new material called PP red, and let's put that onto the where's the camera? Let's put this PP red onto the camera, and if we put the post-processing red, if we go to our material here, we go to the post-processing script, and we put it onto the PP red. Now you'll see that we actually have, where is it? We have it onto the script, and it's going to do that every single frame. The problem is I took our code, and all it does at the moment for the shader is just render the scene as it is. So let's now uncomment this. So we're going to say for everything, the color.rgb is that. Now, one other thing is when we run code, we have this code here, right? Let it save. So let's just press play. There we go. Now, as you see, as we're playing the scene, the post-processing takes effect. So if we, obviously, look, this is what it looks like normally without the post-processing, but our camera actually renders everything in verse now, which is pretty cool. You got your weird post-processing effect there. There's not much more else to that, actually. That's just a simple thing. So just think of it as you're writing a shader for the whole scene. Now, as far as I know, we can actually go up here, and you can... what is it to run something whilst... I know you can run something... Oh, you want to run the whole script. That's it, sorry. We want to run the whole script in... if we do execute in edit mode, it basically means this takes effect while we're just in edit mode before we even there we go. So now we don't even have to be playing for it to be seen, which is cool. And obviously with this now, it's just up to you to take this and basically write your own. So if we go here to our shader and we say, well, instead of having the RGB of each thing be inverted, we'll say like the col.rgb, no, so to col.r, so the red, we can add a 0.1 to it or something. Maybe we'll do 0.3. So we're saying, well, no, that's not actually going to do anything. I don't know if you can write plus equals in the shader language, but we'll get told otherwise if we can't. There we go. So I've just written a thing which takes the color of each pixel and adds red to it, like 0.3 value of red. We can put that up to, we can add 1 value of red, make everything extremely red. So what you would do is you would have this value here. You know what, I'll do it now. So if we say underscore redness, I'm going to call it, well, redness. I don't know if redness is even a word, but then it's going to be a float. So let me just remember quickly how to, it's been a while since I've done the shader coding stuff. Well, that's the one I'm currently on. It's just range, isn't it? Okay. So put range 0, 100. And then if we do, where is it? I'm just going to go along with this. Where do they bring down the main texture? Here we go. Float redness. So if we go plus equal redness, I feel like that'll work. No. Where's the shader? It's expecting an equals. Because it wants a default value. Okay. So where's our material now? Alright. Ooh. Now, as you see, so I put 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 0.8. Now the thing is, what's happening is, when you reach a value of 1 for red, for example, you can't get any higher than that because that's the maximum redness as such. You can't be more red than adding 1 to the red value. If you wanted everything to be red, like literally everything to be red, what you do is you would say, well, we want the red to be 0, and we could also just say the green and blue is going to be, well, nothing. So if you want to have like just an RGB scale like thing, what you'd do is you would put it between 0 and 1. We'll do it. We'll finish the video here. We'll do 2 more of these. We'll call it underscore greenness. These are real words. No, they're not real words. Underscore blueness, and we'll just say, you know, greenness. Yeah, this is these are obviously real words. They're all between 0 and 1. Let's just go down here, and we want to say float greenness, float blueness, and we can just say for every one the color.rg plus g is obviously going to be greenness, and the blue value is we're gonna add the underscore blueness. So if we have it all default 0, what you can do is we can go, that's more red, that's less red, that's more green, it's more blue. Let's go for red, so 0.5 red, 0.5 there, we got purple. We can go for 1, we've got very purple, and we can have that on 1 and tweak it to go pink down to blue. Basically you can go through all this, and obviously you can change it in playtime, runtime, whatever. You can just tweak the shaders. So obviously this is up to you now to take this, whatever you write for your shader in the shader script here is going to be applied to the camera. But anyway, this was a pretty good video I thought I should cover because it's a kind of shader that I haven't covered that is helpful. Obviously people want to write their own post-processing, you can go wild with this. But anyway, I hope that you enjoyed this video. It's been quite a long one, but I haven't done a video in a while, so I hope you like it. As always, if you do like these videos, then like and subscribe would mean a lot. Join our Discord server for help, showcasing, whatever you want. testing out our bot, needing feedback, sorting on our website. There's a lot of stuff going on in the community if you join the Discord. Also, if you don't mind me asking, I have set up a Patreon. The link will be in the description. If any of you are kind enough to donate to help, then that would mean a lot. But apart from that, thanks for watching, and goodbye.